between the two is you're subtracting the two functions because that leaves you with the rectangle between the two of them, right? Wherever it is, whether they're both positive, one's negative, or they're both negative, it works out. Okay, if you say the integral from -1 to 2 of the upper one minus this lower one here. Well, whichever way it is here, right? Whichever one is higher there, right? If we did it the other way, it's just going to be the same number but negative because one's smaller than the other, right? Yes?
Could you do like the integral of f of x minus the integral of...
Yeah, because you can split this apart into two integrals. Yeah. So whether you're thinking of subtracting the heights of the functions, remember what the integral is. You know, our integral is, when we do this, it's basically the sum of all the heights times the widths of the rectangles, right? That's all that is. This is when you make the rectangles infinitely skinny, this is their width and this is their height, right? So those are the two numbers that matter there, right? So your question is, can you write it as two separate integrals? Absolutely right. Anytime you have an integral like that with two functions subtracted, you can make it two separate things like this. Minus integral from -1 to 2 of g of x dx. Okay, you can write it as two separate things or leave it as a single thing. I guess I could have written it up here with those two specific functions. 2 minus x squared and minus x. So this is integral of 2 minus x squared minus -x, yeah, dx. If I'm doing it as a single integral, it doesn't matter if you do it as whichever you're more comfortable with here. -1 to 2 of, what do we have here? 2 minus x squared plus x dx. You can, again, do it analytically or do it on the calculator with technology. Doesn't matter. You can do it numerically or analytically. If you did that analytically, you need an antiderivative, right? Antiderivative of that is 2x minus 1/3 x cubed plus 1/2 x squared. And evaluate that for -1 and 2. Blah, blah, blah. You'll get an answer, right? Or you can use the calculator, right? Again, maybe we can dispense with this. Oh, not there. Function itself. Okay, you put the function itself, so 2 minus x squared plus x. If you do it analytically, it should work out to that. Perhaps, Mike, you could go somewhere else, okay? Find people in the hallway you can impress with that. Really. Or just talk to yourself in your own head for a sec. Oh, I didn't actually have it going, you know. Well, that's what it ends up being, right? 9/2. This one? Here you have to... well, finite just means... It means... it's a way of saying... If you just say find the area between these two, well, somebody might think, well, this is between the two. They mean, when they say finite area, they mean between the two, the closed part, not the open part. Okay. Okay, when they say the finite area. So it's between 0 and... 2 over x. Well, let's go with this for this one. 2 over x and y equals -x plus 3. This 2 over x looks something like that. That's actually a, what is that? Where does that intersect at? Square root of 2, but that doesn't matter. It passes through 1, 2, and 2, 1. And you have -x plus 3, right? Y equals -x plus 3 if you're graphing it by hand here. Does it actually intersect it something like that.
No, it intersects at 2. Well,
Okay,
I'll
so
try and zoom in.
so this is 2.
It intersects in 2 and 1.
Yeah.
I'll zoom in.
So this is not, my scale is a bit off there, but that's okay. So you're looking for this tiny little area. When they say finite area, they just mean that, right?
Yeah, that's pretty small.
You want this function minus this function.
I got over there.
Okay, that area is integral from, you need to know those points. If you can see what they are, put them in. Integral from 1 to 2 of the line. Okay, line minus the hyperbola there. So you have negative x plus 3. You have to be able to express it as like as a function of x. Y is a function of x. If it helps you to call one of them f and one of them g or something like that, please do. You can't leave it the way it is, the way it's given there. You need to express it as a function like this, where this is explicitly on one side like that. So negative x plus 3 minus 2 over x. You don't need to put those in brackets. I'm just doing that because with other functions it might help. As two separate integrals or as one integral together. If you're doing it as one integral together, you're likely thinking about it as you're subtracting the heights. Each of the little rectangles you're finding, the height is the difference between the two functions. If you're doing it as two separate integrals, you're thinking of this area all the way down to there minus this area underneath, right? And that leaves the yellow part there. Whichever way you're thinking about it, right? Whether it's two separate integrals or one together like that. Okay, so for this unit, this is applications, so we've done all whether you want to do it analytically or on the calculator or do it both ways and check, absolutely fine. I'll let you come up with an answer for that. If you're doing it analytically, negative a half x squared plus 3x minus, what is this? 2x to the negative, this is minus 2x to the negative 1. What's the integral of 1 over x? Yeah, ln of absolute value. And now, what I would say is, as soon as you have to go to the calculator to start doing this analytical stuff, you might as well just do it numerically. Does that make sense? If you have to go to your calculator to evaluate a natural logarithm, just use the calculator to do it numerically in the first place. Right? Because you're going to have the calculator to be able to do this. Unless you're expressing it, like if you're going to UBC next year, you have to get used to what they call calculator-ready answers. So a calculator-ready answer is putting in all the numbers you can and then saying ln of whatever it is here, 2 or something, minus ln of 1. They don't like calculators there because you might cheat. They don't like calculators. This is a topic for another YouTube video, I think. But no, UBC is a pretty well-known university. But what do you come up with for an answer there if you go to your calculator analytically here or numerically? Negative x plus 3 minus 2 divided by x. Did I put it in there right? Comma, x is the variable, 1, 2, something like that, 0.1137. Again, make sure you're putting an approximately equal to sign if you're rounding something off. Is that going to be able to be turned into a fraction? Why not?
Because I did it on my calculator.
No, but why isn't it? Yeah, because it's a natural logarithm, right? Which isn't a rational number. So. All right. I put a lot more questions in here than you need, right? I mean, it's setting up the integrals is the thinking part here. If you don't have those intersection points, you're going to have to find them, right? And if you have to go to your calculator to find them again, you might as well do it numerically on the calculator, unless you're going to UBC and then you have to do everything the other way.